Okay, in this video I'm going to solve problem 7 shown here, and it gives you 5 different permutations. Okay, and it says they're written in standard notation, so that means they're not written in cyclic notation, and in fact I could rewrite permutation 1 like this: 1, 2, 3, 4, 5, and then 1, 3, 2, 4, 5 is the pattern that permutation 1 has. And so this permutation maps 1 to 1, it maps 2 to 3, it maps 3 to 2, 4 to 4, and 5 to 5. And so what fixed points, if any, do each of these permutations have? And so permutation number 1 has fixed points at 1, 4, and 5, because 1 is mapped to 1, 4 is mapped to 4, and 5 is mapped to 5. And so from the standard notation we can look to see whether or not we have any 1s in the 1 position, any 2s in the 2 position, 3s in the 3 position, 4 in the 4 position, or a 5 in the 5 position. So the fixed points, let me write the solution for part A. Okay, so here's the fixed points for P1. 1, 4, and 5. Okay. For permutation P2, I can write it like this. 2, and then the pattern for 2 is 2, 4, 3, 1, 5. And you can see that we have a fixed point. We've only got 2 of them, 3 and 5. For permutation 3, we can write it like this: 3, 2, 4, 5, 1. And you can see that we have a fixed point of 2. Just 2. P4. We can write it out like this in longhand. And it's a pattern of 5, 2, 3, 4, 1. And we have fixed points at 2, 3, and 4. Finally, P5 can be written in sort of expanded notation as 5, 4, 3, 2, 1. And we have fixed point. You can see the 3 and the 3 line up at 3. Okay. Next, we're going to do part B, which is to write the permutation in cyclic notation. And for cyclic notation, we're going to put cycles in parentheses. And so for P1, we can write that 1 is fixed. We have a cycle between 2 and 3. 4 is fixed, and 5 is fixed. And we can omit the fixed points and just write 2 and 3 if we want. Okay? For permutation P2, let me cordon this off a little bit here. For permutation P2, we have 1 mapping to 2, 2 mapping to 4, 1 to 2, 2 to 4, 4 back to 1. And that completes the cycle, 4 back to 1. Next, we need to figure out where 3 goes. 3 is fixed and 5 is fixed, so we can write 3 and 5. And again, we can omit the fixed points and write 1, 2, 4. Okay? For permutation P3, we have a cycle starting at 1 to 3, 3 to 4, 4 to 5, 5 back to 1. So 1, 3, 4, 5, 1. 1, 3, 4, 5, and then cycles around back to 1. And that leaves 2 as our only fixed point, and so we can write that as 1, 3, 4, 5 as the cycle in cyclic notation. Permutation number 4 in cyclic notation. I hope you can start to see this now. From 1 to 5, 5 back to 1. So 5 and 1 is a cycle. 2, 3, and 4 are all fixed. 1, 5, 2, 3, 4. And we can write that as 1, 5. Finally, permutation number 5 goes from 1 to 5, 5 back to 1. So 1, 5 is a cycle. And then starting with 2, we're going to go to 4 and then back to 2 again. So 2, 4 is a cycle, and 3 is a fixed point. And so this can be written as 1, 5, 2, 4. Okay. Finally, we want to write the inverse of each permutation. And I will do that in green. And I guess I didn't quite leave myself enough room for permutations 2 and 4 to have inverses. Permutation number 1, and I'm going to write the inverse in standard notation, so a single row. So P1 inverse is equal to. Where does 1 go? And when I do this, I'm going to look at this expanded notation. I'm going to say 1 goes to 1, 3 goes to 2, 2 goes to 3, 4 goes to 4, and 5 goes to 5. I'm going to go upwards. Okay, so first I'm going to look at 1 goes to 1, then 2 goes to 3. 1 goes to 1, 2 goes to 3, 3 goes to 2, 4, and 5. So there's the inverse of P1. P2 inverse I'll do over here. P2 inverse, actually I'll do it a little bit further down here. Yeah, plenty of room. Okay, P2 inverse. Let's see, P2 maps a 1. If I look at the mapping upwards, it maps a 1 to a 4, a 2 to a 1, a 3 to a 3, a 4 to a 2, and a 5 to a 5. So a 1 to a 4, 2 to a 1, 3 to 3, 4 to 2, and 5 to 5. P3 inverse, I'll write right here. And P3 inverse, hopefully you're getting the hang of it. I'll show it again. It maps a 1 to a 5. We're going upwards now. 1 to 5, 2 to 2, 3 to 1, 4 to 3, and 5 to 4. And so 1 to 5, 2 to 2, 3 to 1, 4 to 3, and 5 to 4. P4 inverse over here. P4 inverse, a 1 goes to a 5, 2 goes to 2, 3 to 3, 4 to 4, and 5 to 1. 2, 3, 4, 1. Finally, P5 inverse. 1 goes to 5, hopefully you're getting the hang of it. 2 goes to 4, 3 goes to 3, 4 goes to 2, and 5 goes to 1. Okay, so this is problem 7, and I've looked at fixed points, I've written them in cyclic notation in blue, and I've written their inverses in green. Hope that helps.